less work on those things. Some of this will be familiar to you, some of it maybe a little bit new. Remember to go to the Moodle page and click on that link for the click on the link where the notes are for this, because that's going to be a little bit easier for you to take notes, because there's a lot of words and you're translating words into algebraic expressions or equations, and so you're going to need that. Otherwise, you're going to have to pause me a lot to get the question written down and then replay to get the work down. So try to be proactive and maybe pause me now and get that printed out first if you haven't already. All the examples we're going to be doing are in your book. We're starting on page 57. Some of the examples will be on page 59. So here we go. I can write algebraic equations from verbal sentences and problem situations. So there's your target for today. Get that at the top of your notes. Please remember to be labeling your notes with the lesson so that when your partner checks them, it is easily identifiable about what they're looking at. All right, writing equations. An equation is a mathematical sentence containing two expressions separated by an equal sign. An important skill in algebra is modeling situations using equations. So what we're going to be doing is reading a situation and being able to write it, model that by creating an equation. Notice equation is highlighted. It is a vocabulary word. Please make sure you're keeping that up to date, as it will be due the day of the chapter test. So, some important things for identifying an equation that fits a situation. Words. They describe the situation, use only the most important words. Sometimes it'll say, you know, Jennifer's going shopping. Jennifer spends $20. Obviously, her shopping helps you understand the situation, but to make the equation, you only need to know that she's spending money and what she has, etc. Step 2 is defining the variable. You're going to need to be able to do this and show what your variable represents. And you'll assign a variable to represent an unknown quantity. So say I was looking for the total amount of something. I may pick T, or I may pick A to represent what I don't know. For an equation, you're going to translate your verbal model into an algebraic equation. Okay, so those are kind of 3 steps. First, you have to pretty much read, decide the letter you're going to use, and then put it into an equation where something happens and you end up with a certain amount, but then you have to find that variable, which will lead into our next lesson, 1.9, will be solving equations. All right, so our first example, try this one together. This is again on page 57. So you're going to write an equation to model the situation. We do not need to solve, we just need to write an equation for this, because my directions tell me that. So here I see that it says the winning time of 27 seconds was 2 seconds shorter than Tina's. So right now what I know is I know the winning time is 27 seconds, and I know that that was is a form of is, so I think this represents an equal sign. So 27 is 2 seconds shorter than Tina's winning time. Do I know Tina's time? No, I don't. So that's going to be defining my variable. So I decide that T is what I don't know, which represents Tina's time. Lots of T's involved there. Tina's time. What I do know about Tina's time is that it was 2 seconds shorter than. Shorter than sounds like less. I know that less is a word for subtraction. So I can think that this 2 seconds shorter than is minus 2. Well, minus 2, Tina's time is 2 less than the winning time of 27. Okay, so 27 is the winning time. Can we go back and re-look at this? 27 was, this is like is, 2 seconds less than Tina's time. So obviously Tina's time was more because she wasn't the winner, but it's 2 less. Clearly from this you know that Tina's time was 29 seconds, but you don't actually need to solve. Okay, so sometimes you have to work a little forwards, backwards, and you definitely have to go back and reread your mathematical sentence and see if it matches up to what your verbal sentence would have said. Okay, let's try this next one now that we're got our feet wet a little bit. We're a little less rocky. So this one says, and still on page 57, a drop of 4 degrees per hour for the last several hours resulted in a total temperature change of negative 24 degrees. I just read. So step 1, I read it. And I need to pull out the important information. It says a drop of 4 degrees per hour. What I know about a drop in 4 degrees, I know that that represents a negative 4 per hour. I know that means that it's dropping for every hour that changes. And I don't really know how many hours are here. It just says several. So I'm going to have H represent the number of hours that have passed because I don't know that. What else I know is that that resulted in a total temperature change of negative 24. Resulted tells me that something equaled that amount. Okay, so you might interpret these little different ways, but I'm kind of helping you decide and see how words are interpreted to me, and that there's different ways to say equals. There's different ways to say times, and you just kind of have to read the problem and think it through about what makes sense. So what I understand here is that the temperature drops, so negative 4, every hour, and it ended up being negative 24 degrees. So it's really how many hours did it have to drop 4 degrees each time to end up dropping 24 degrees. Okay, so that's kind of what that means there. That can represent that situation. Next ones we're going to be doing, make sure if you have questions, you're writing them down on your notes. When you do your NICU, fill in different questions or flag different things and write your confidence. I see some people are doing their confidence on those. Others could do a little bit more, not rush through those things, and really try to do your best. Page 59 now. And these notes are printed again. You can get them off Moodle. We're kind of jumping over to page 59 in your textbook for following along. I'm going to just look at my directions quickly. My directions tell me to define a variable. Defining something's when you state what it means. So every time I determine a variable, I'm going to put the letter out there. And so in this case, I could say it's V stands for variable. You're always going to want to say what your variable stands for, so it's very clear about what the problem means. Okay, so then you're going to write the equation to model the situation. So first we have to figure out what are we going to use to represent what we do not know. So number 1, Kevin's score of 20 points was 4 times Corey's score. Right here we see that Kevin's score of 20 points. So we know Kevin's score. The score we don't know is Corey's score. Some people might use S for score. In my case, my S's tend to look like my 5s sometimes, so I'm going to play it safe, and I'm going to use C for Corey's score. And this is me defining my variable. Now I know exactly what C represents. Now I can go back and write an equation to model Kevin's score of 20 points was 4 times Corey's score. Again, I see that word was. That means I'm comparing 20 to something else. That is equals. 4 times. 4 times, I knew 4, and I know that's multiplication, and I don't know Corey's score. So a way to write this is that 20 was 4 times Corey's score. And I just like to reread this. 20 is 4 times Corey's score. If I reread what I write, and it matches what the original sentence said, then I know I'm in good shape. So I define my variable, and I wrote my equation. You're welcome to pause me and try the next one, or follow along and just write it out. Maybe you put a line down your page and you do yours, and then you do Miss Simmer's over here, and kind of compare them, see what they look like. Or you can do whatever your heart desires, as long as you're following along and taking some notes for some learning. So next we see the total was $28 after a 4 tip was added to the bill. Let's find out what I need to know, what I don't know currently and I need a variable for. It tells me the total was, that means the total bill is absolutely 28. So 28 is equal to something after a $4 tip was added, tells me I'm going to be using addition, to the bill. Well, right now I know the value of $4 was added to something, to the bill, but I don't know how much the original bill was. So I'm going to make my variable b equals the total, I guess it would be the total bill, because 28 was the total bill. See, we make some mistakes sometimes. B would be the original bill amount before the tip. So B represents the bill before the tip. So now we know that 28 is equal to a $4 tip plus the amount of the bill, whether it's food or whatever it is that you're paying for. So that equation matches that situation. My variable is clearly defined to match the situation. Hopefully this is going okay so far. We're going to do a couple more examples, and then I'll send you on your way to get ready for class and do your NICU. Again, we're going to be placed very close attention. We need defined variable. If the directions say that and you don't have it, then you didn't follow those directions. So 3, submarines. A submarine dove 75 feet below its original depth. If the submarine's new depth is negative 600 feet, what was the original depth? Well, it tells me right here what was the original depth. Since that's something that's unknown, that must be what I'm looking for. So I could make O for original depth. But something that might be wrong with picking O is that it looks a lot like 0. So I'm going to say, I'm going to use D to find the original depth. D just seems like a way safer letter to use so that if my handwriting gets a little wild or someone else is looking at it, it's not confused for a 0. What else I notice is that a submarine dove 75 feet below. 75 feet below, that's going down 75. Where did it go down from? Below its original depth, which we know is D. So some people might, this one I'm going to show that you could write it a couple different ways. And then it tells us that the submarine's new depth is, whenever I see those is and those was, that's equal to negative 600. So I know that it ends at negative 600, but I want to know what its original depth is. So my original depth, well, how did I get to negative 600 from there? And it looks like I went down 75. Some others, what I might have done differently, what I know the same thing, subtraction's the same as adding the opposite. So I could say from the original depth, I went down 75, add a negative to get to negative 600. That is also the same kind of situation. So I can read that to make sure it matches my situation. From the original depth, we went down 75 feet and we ended up at negative 600 feet. Number 4 here, testing. This one can be a little tricky, so you gotta pay attention. The total time given to take a state test is equally divided among the 3 subjects tested. If the time given for each subject test is 45 minutes, how many minutes long is the entire test? What we do know is that the total time given to take the test is equally divided among 3 subjects. So, and I'm looking for the entire test, which is the same as the total test. So I'm going to have my T represent the total test, the total time of the test. What I know is that that is equally divided by 3. So the total test is equally divided by 3. Could also look like T divided by 3. You can use a capital T if you wanted. As long as you define it, whatever I use here is what I'm going to use in my equation. And the total test divided by 3 gives me is 45 minutes per tests. So the total tests divided by the 3 subjects gives me 45 minutes per subject. So this matches the situation. And if I wanted to find out how long the total test was, I would just multiply that 45 times 3. But I don't need to do that in this situation. It just wants me to define an equation. Last 2. 59 again. Javier is 4 years younger than his sister Rita. Given J, Javier's age, write which equation of the multiple choice below can be used to find R, Rita's age. Sometimes you're given variables. In this case, we know that J stands for Javier's age, R stands for Rita's age. Okay? So what we really need to determine is the relationship between the two. What we know is that Javier is 4 years younger than, that sounds like less than Rita. So it sounds like younger than is kind of a less than situation, which I know is subtraction. So you just kind of have to determine which one would I subtract from. And with multiple choice, you can kind of look at, well, which one doesn't make sense. So A, if we will look at that, which doesn't make sense. Javier's age is Rita's age divided by 4. That would mean that Javier is 4 times less her age. Well, we don't say anything about times and dividing. That doesn't seem quite accurate. B says Javier is Rita's age plus 4 years. That would mean that Javier is older than Rita. But here we know that he is younger than Rita, so that also doesn't make sense. Notice how I can read the equation and see if it matches the situation. You have to be able to use the words in math kind of interchangeably. C here says Javier is Rita's age minus 4, so 4 years less than Rita. If you go backwards, 4 years less than Rita. So that sounds about right. Now if I just check on this one just to make sure, Javier is 4 times Rita's age. But Javier is younger. There's no way he's older, 4 times as old, so that's not true either. Okay? So kind of eliminating and checking your work is possible through those conversations we want to be having in class and talking things through and thinking them fully through instead of just doing some quick math and moving on. All right, last one. Again, we see that we need to define the variable first, okay? And then write an equation that matches. After dropping 12 degrees Celsius, the temperature outside was -5 degrees Celsius. I see dropping -12. I see temperature outside was, I know is equals, and -5 degrees. It looks like the only thing I could be trying to determine is the temperature. What was the temperature outside before it dropped? So I may label T is the temperature. T for temperature before dropping. So what I know is the temperature was a certain degree and then it dropped 12. Drop would mean going down 12, and then the temperature ended up at -5 degrees. So that's how you're able to solve those, okay? So I'm going to need a lot of, definitely you're going to want to write on your, do some writing in your work tomorrow. You're going to want to use some underlining, some highlighting skills, and just kind of keeping track of the information that you need. I know this was kind of a little bit longer of a one, and it was a little bit wordy and kind of stumbly through, and sometimes you do things differently than I do, you interpret differently. Just kind of have to open your mind to what do words mean and what are they trying to tell you. So you can rewatch this, look in your book a little bit more, use those personal tutors. Just make sure that you take the NICU and you take your time on your NICU and write down some questions in your notes that you want to bring to class tomorrow.